Hi everyone, let's get started with coding by looking at Google Colab, Jupyter Notebooks, and Numpy. So let's jump into it. Okay, so let's go to Google Colab. So here in the URL, I'm going to type colab.research.google.com. And it takes me to this opening page. You can see there's a number of options. I can create a new notebook down here, and I can resume notebooks I've already started. Here's a notebook created by Google itself, just a welcome notebook. If you click there, you'll get information about what is Colab, this collaboratory, and also some resources you can use. So if you need help with Pandas or some other aspect, this is a good one of the many resources we'll talk about that may be helpful in your journey to become, gain more expertise in machine learning. Let's go back to that page that we had. One option is to open something from GitHub, and I'm just going to show you how to do that right now. So I'm going to click the GitHub tab, and here it says enter a GitHub URL or search by organization or user. So here's my GitHub account, and this is where you'll be going, and it's github.com/zaharsky/ml-class. If you go to labs here, that's really all you need, but let me show you the one we're going to be opening is numpy.ipynb for Python Notebook. So I'll go ahead and click it, what the heck. And here in GitHub, we can kind of see what that notebook looks like. It does a good job of rendering all that information. But what I'm going to do is copy the URL. So I'm up in the URL area. I'll just copy that to my clipboard, and I'm going to paste it here and hit return. These are all the files in there. I'm going to look for that. There's Numpy. That's the one we want, so I'm just going to open it. And there we get the notebook that we're going to be working through on our own. Not here in the video, but after the video, you can work through this material. As I mentioned before, a Jupyter notebook consists of different blocks of information. Some blocks are code and are executable, and other blocks are text information, some documentation written in a markdown language that we talked about. So a Jupyter notebook is a set of these blocks. In Jupyter Notebook notation, those are called cells. So a Jupyter Notebook consists of a number of cells, and a cell can either be text, meaning documentation, or code, meaning something that's executable, some Python code we're writing. So this first one here is in Markdown. It's just some information I'm presenting. And if we double click there, it'll open up and you can see what the code was to generate those tables. When we want to execute a cell, whether it's code or text, we can simply press Shift Enter, and it'll return that cell to its markdown formatted look. Way down on this page, we have some math formulas. And here you can see them. They render fairly well. If you want to see, well, how was that done in Markdown, you can just double click that cell and scroll to where those are and just see what the formulas are that created, or see what the code is that created those formulas. And again, to get out of that view into the formatted view, you just hit Shift Enter. So that's all I wanted to talk about regarding this Numpy notebook. You'll be working on it on your own. Now, there is a tendency just to kind of go through the code without thinking, without engaging your brain, right? You can just kind of click through these cells and execute the code, and it runs and it produces some output, but you really don't understand it. So what you really need to do, and why I'm not kind of lecturing completely on this material but taking a slightly different track, is to go through the notebook and try to understand as best you can what's being involved. If you have questions, talk to me or correspond to me. All right, so instead of going through this notebook and reiterating the same material twice, I'm going to take a different orientation of the material and open up a brand new notebook. So under this File menu, I can say New Notebook. Okay, and here I am. Let me just make that a tad bigger. So this is a code cell, and I can write executable code. So let me say, let's say I was driving between Virginia and here to Santa Fe, and the number of miles that is about 1,820 miles. And I have no clue how many gallons of gas that would take, but let's say it takes 97 gallons. And I want to know what my miles per gallon was on the trip. So MPG equals miles divided by gallons. Initially, it takes a while to get everything running, but after that, if I execute that cell again, it'll be very fast. If I want to see what I should have added, a print statement, so I'll go back there and say print MPG. So we're going to print the miles per gallon. You see we get help every time I write something, so we can execute this cell by hitting Shift Enter. Another way is hitting this Run box. And now I get that value printed. If that was indeed the gallons I used, it would be 18.76 miles per gallon. And if I go to another cell, this cell, all the cells in a notebook, all the code cells are in the same environment, meaning that this cell knows what miles equals and gallons equals or MPG equals. They're not isolated independent cells, but they work together in an environment. So if I say print MPG here, it knows what MPG is. So all through this document, it knows from top to bottom what the value is. So let's, instead of those, let's create a text cell. So I can either kind of put my cursor on this last cell and select text. Alternatively, I could have gone up here and said add a text cell. And let's make a header, intro to Numpy. And let's make a subheader. So there I made some textual notes for myself. Okay, and importing a library into Python is very easy. Let's import NumPy. You just say import. Okay, and now let's say I want to create an array. So that's just a name I give it. I could give it anything. I can give it the name Bodhi equals, and just list what I want as the array. And now if I say what's Bodhi, it'll say it's an array 1, 2, 3, 4. I can make a 2D array. Let's call it array 2D. So that's the first row. There's all these hints that are popping up and probably distracting you more than helping, but most of the time they're helpful. And there we get that two-dimensional array. So you may be thinking, why do we have this NP? So we have import numpy as NP. What's that all about? NP is an alias. So instead of having to type in numpy, we can type in NP. So let me just illustrate that. So if I say import numpy, then I would just by itself, without that as, I would have to say array 3 equals numpy. So I'd have to type in that whole word numpy versus NP. So NP is an alias for numpy. So it doesn't look like a big deal, but as if we're using NumPy a lot, that savings of a few keystrokes might be, motivation to do it. And this import, I'll just repeat it here, import numpy as np, that's the convention. So people use np. I could use anything I want here, deep learning library. So I'm free to use whatever name I'd like. But then if I created an array, this is the worst possible name. Right, so that would be not a very good way to do it. And so we end the import numpy as something is just creating an alias. And the convention is, again, to use np. I just created a text box there, a markdown, and let's just look at other ways of creating an array. And let's just look at the Python example. Okay, that's kind of nice when we're kind of playing around that we can keep track of what we're doing. So I want to create an array in Python. Hopefully we all know how to do this. And let's say I just want to create an array that goes from 0 to 10. So I can go so if I ask what p-array is, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So range 10 returns what's called a range. It goes from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then for every element in there, it's just putting that element in an array. Well, let's say I want to do a two-dimensional array in Python. So I'd keep that x. That created the one-dimensional array. Let's change it a bit and keep it 10 by 10. And then, oops, I need to add a so we have one for loop starting with using y. Y goes 0 through 9. And we have another one for x embedded in that, also going 0 through 9. And here we're just creating that value for each element in the array. Let's just print out that array, maybe. And there we see what we did, right? So the first time through y is 0, and x ranges from 0 through 9, and we get 0, 1. So x is 0 initially, y is 0, so we get 0 plus 0 times 10, which is 0. That's that first 0. Now x is 1, x 1 plus 0 times 10 is 1, and so on. It just iterates through creating this array. Let's add a comment here in NumPy. So how can we do it in NumPy? That's very easy to do, so we don't need to import. So we don't need to import NumPy. Why? Because we've already imported it in this Jupyter notebook. NumPy has a similar thing to this range in regular Python, but it automatically creates an array. So it kind of does, let's go back to here. So it kind of does this all in one fell command, this x for x in range 10. So let me show you how that works. Let's call it let's just call it an array. Array range, so we can just specify what the range is, and let's say it's 100. So there we go, from 0 to 99. So, but we didn't want this in one dimension, say we wanted it in 2 dimensions, just identical to how it was up here. For that, we can use a the NumPy reshape command. So we can reshape this long one-dimensional array into a different shape, namely the 10 by 10 array. So we have an array. Whoop. Maybe. I'm going to reshape it. And I want it 10 by 10. And there we have it in that identical form as in Python. So I'm hoping you see it's a tad easier to do in NumPy than it is to do in Python. We can get the values the same way. Oh, let me save this to call it something. All right. We get the values of NumPy arrays the same way we do in regular Python arrays. So if I go n array 3, n array 3 is 3. And why is that? So up here, we have this n array, and the 0th element is 0, first element is 1, second 2, the third element is 3, and that's what we printed. For two-dimensional arrays, we can say an array 2, which is the 2D one, and then this is the row we want. So let's say I want the first row, the third column. I get 13. Right, the first row. Oop, I didn't print out an array 2. Let me do that. So the first row, this is the 0th row. The first row, the third column. Is that what I said? 0, 1, 2, 3. I get 13. So that's how you index and get values in NumPy. So basically, it looks like, hey, wait, NumPy looks identical to Python. Why bother loading that library when I can use Python? So let me illustrate why we'd want to do that. So again, let me make a note here of what we're doing. And this time, all the same stuff as Python. Why bother? Well, let me add a bit to this. And the answer is it's speed. Well, let's see how fast the Python version is. I'm going to time it. This is the same as what we did before. Just a larger array. Let's make it 1,000 by 1,000. Looks good. Okay. Look at. I think that looks reasonable. I'm just going to make it small so I can see if I am missing a bracket. No, looks good. Okay, let's execute that. So it took 158 milliseconds wall time, user time 108 milliseconds. Let's try the same thing in NumPy. NumPy T1 equals. So there's going to be a million entries. Oh, come on, dude. And I'll reshape it. Oops, I'm missing a parentheses here. And you see it took significantly less time, right? So the answer is why NumPy versus Python straight Python. NumPy is so much faster. Let's look at another example. Let's say I want to add, go here, add another text. Let's say I want to add 1 to each element. And first we'll try it with Python. All right, to do this, I'm going to write a function. Let's call it add1. And I'll need embedded for loops. That looks right. So for each element, I'm going to add 1 to it. And let's time that. So it took, similar to the time it took to create it, the wall time is 144 milliseconds. Let's time the Numpy version, see what that's like. And you can see there is significantly faster user time. The wall time 7.34 milliseconds. So again, any operation on matrices, these aren't even that large, and you see the superiority of using NumPy. So that's kind of the reason why NumPy is such a big deal in all of data science and in all of machine learning. Finally, let's take a look at some NumPy functions. NumPy has a lot of functions that deal with matrices. Let's just look at a few of them. So I can use this array that we created and get the average value. We can sum them all together. And when you are kind of stuck and don't know what something means, the documentation for NumPy is great. So let's say we wanted to use something called argsort. We saw that somewhere and we thought that might be useful, but we don't know how to use it. If you just simply Google NumPy argsort, it'll take you to that documentation. The NumPy manual gives you all the information about the argsort, but the better thing is it gives you a large set of examples. So fantastic documentation. So that's kind of covering the basics of NumPy. Let's say I want to keep this notebook for future reference and Untitled 14 just doesn't do it for me. I can rename it by just kind of hovering over that value and saying rename notebook. And let's say I want to call it my NumPy intro. So let's say I leave NumPy, leave for the day, and tomorrow I come back, go to Colab, you can see that it's saved there, NumPy intro. And we can just, it doesn't remember the value, so if I went down, way down to the bottom and typed in MPG, it may not bring back this 18.76. It just so happens this isn't the next day and the machine's still running. But you just would need to start from the top and execute those cells. So that's a way of saving for yourself. What about if you wanted to save to GitHub? So under File, I can save a copy in GitHub. It says I need to authorize. So I'm going to authorize Google Colab. I'm going to confirm my password. Oop, let me type in the password instead of letting it autocomplete. And it gives me what repository I want to use. I guess I don't want to use alien abductions, but I have, as I mentioned before, more machine learning demo 22. Sure. Let's say I want to put it in machine learning demo 22. I'll just click there and I can create, let's say I want to stick those all in labs. I'll just go like that and hit this OK button. And you see I'm now in GitHub and my file, that Jupyter notebook, is saved in GitHub. So that's basically it. I think that covers kind of the basics. Again, the super helpful thing to do would be to go through this and just try to gain some better understanding of NumPy. Even if you know NumPy, it's probably worth just going through and kind of doing a refresher. And that's it for this video. In the next video, we're going to cover Pandas and kind of the same method. There'll be an independent notebook, and I'll talk a little bit about Pandas. So thanks very much for watching. Take care. Bye.